So first order predicate logic. In this logic we are going to discuss the resolution. We are given these sentences, we will convert these, we will resolve this by using predicate logic. So first of all, convert these English sentences into the first order predicate logic, that is fall. Take one by one. John likes all kind of food. If we take food X as X is food and likes John comma X as predicate which John likes X. So by using these two predicates we can say this sentence is for all X. So food X implies that John likes X. So this is the sentence for John likes all kinds of food in predicate logic. So now see the next sentence, that is apples and vegetables are food. So first is apples are food. So apples are food, it means food apples, and vegetables are food. Vegetable is we can take X as vegetable X as X is vegetable. So we will bifurcate this sentence in predicate logic into food apples, and for all X, vegetable X implies that food X. So all vegetables are food, it means all vegetables are food. So these two sentences in predicate logic make up this sentence, apples and vegetables are food. Next is anything anyone eats and is not killed by is food. So anything anyone eats and is not killed by is food. So we take eats Y eats X as eat Y comma X. X kills Y as kills X comma Y, and X is food as food X. So for all X and for all Y. So anyone eats anything, for all it means Y eats X, eats Y X, and kills X Y, X kills Y, and we are using a negation not before it. So if someone eats Y eats X and X does not kill Y, then it's food. So food X. So this we represent this sentence of English in first order predicate logic. So next is Harry eats everything. Anil eats. So we can use Anil eats X as eats Anil comma X, and Harry eats X as eats Harry X. So for all X, eats Anil comma X implies that eats Harry comma X. So whatever Anil eats, Harry also eats. So this sentence represents it. And next is Anil eats peanut and still alive. So first is Anil eats peanut means eats Anil peanuts. The first part, and still alive means peanut does not kill Anil. So kills peanut Anil. Peanut kills Anil. We are using negation with it. It does not kill. So kills peanut Anil. We are using negation with it. So these are all the sentences which are written in first order predicate logic. Now our goal is to prove that John likes peanut, means we have to use likes John comma peanut. So this will represent the sentence John likes peanut. We have to prove it. So by using, if we want to prove it by resolution, then we have to do it by contradiction, as you know. So first of all, convert fall first order predicate logic to CNF. So let's convert first order predicate logic to CNF form, that is conjunctive normal form. So basically given English sentences, we have converted it into the first order predicate logic fall, and these predicates or these sentences we have to convert them into conjunctive normal form. So the rule is, if P employs Q and we want to convert it into we want to eliminate this implies sign, and we have to write not P or Q. And similarly, if not simple is P and Q and we want to carry it inwards, then we can carry not P and symbol becomes or not Q. So we will use these two rules for conversion of these predicate logic expressions to the conjunctive normal form CNF, that is fall to CNF. One more is that in conjunctive normal form we eliminate all there exists, we eliminate these, and these will become for all, and we can drop for all x because it's already understood that all the expressions are for all, so we will eliminate there exist. So if there any there exist occur, we will eliminate it. So let's do the first one is for all x food x implies like John x. So there is implies sign, and to eliminate this we will use the formula this P implies Q, negate the first, put or and second. So we will negate the first, not food x, or and the second one like the John. So it becomes not food x or likes John x. So similarly food apples will remain food apples as it, and for all x vegetable x implies sign and food. So when we want to eliminate implies sign, we have to negate first, not vegetable x or food x. So for all sign is there, we can leave it. Here for all sign is there, we can leave it. Next is for all x for all y eats y x, y eats x and kills x kills y with the negative sign, and implies sign is the food x. So if both the condition are true, it's food, x is food. So convert this expression into CNF form. First of all, to eliminate this implies sign, we have to negate the first one. Whole of the expression will be negated, not sign, and put a long bracket, all this in this bracket, eat yx and not kills xy. So this is the P, or this is the Q, food x. So we have changed this symbol to or symbol. Now carry this negation sign inward, it will be applied to both eats and kills. Kill is already negative, there will be two signs, not and not. For eat it will be single sign, not eats yx, and this and becomes or not, again in brackets, not kills x. And we know that if there are two nots, means not P and there is another not of not P is equivalent to P. So not P is equivalent to P. So this not kills is equal to kills xy, and this is not eats yx and or food. So this expression is equivalent to this. These two expressions are equivalent. So now next, for all x eats nil x implies that eats Harry x. So we have to just eliminate this implies sign, negate the first, put or and write the second. So we have written not eats nil x. So we have negated first one, or sign or implies sign has been converted to or sign, and second expression as it. So similarly eats nil peanuts, it will remain same, eats nil peanut, not kill peanuts anil, not kills peanut anil. So these will remain same. Now we have converted our expressions into the conjunctive normal form, which is required for the resolution. Now we will resolve this. First of all, our goal is we have to negate this. Our goal is that John eats peanut means John likes peanut. We have to negate that. Our expression like John peanuts, we will put negative sign before it. So we always make our goal negative. We start from the negative expression which we want to prove. We want to prove that John eats peanut means John like peanuts, but we start John does not like peanut, and we will prove it false. So let's do. First of all, in resolution we start from the, this is step 3 in resolution. First was the predicate logic expressions, second was the conjunctive normal for expressions, and third one is the resolution tree. We will make a tree. Start from the expression which is not likes John peanuts, and we will find expression from our calculated expressions that which have a positive predicate likes John peanuts, and that expression is you can see from the expressions there is expression not food x or likes John x. So this one is positive and this one is negative. So but the thing is that the arguments are John and peanut. Here arguments are John and X, and we will make a substitution for X. What substitution? We will substitute X for peanuts. Where in this question, wherever is X, we will substitute it with peanuts. So it will become food, not food, peanuts, or likes John peanut. So we will make now these two expressions, like John peanut and like John peanut are equal, but this is a negative expression, this is positive expression. When we combine, these two expressions will cancel out. We will be left with only this expression. So for resolution, we will cancel out negative and positive expression which have same number of arguments and which have same arguments. So we are left with only this, not food, peanuts. So this is the process of resolution. Now find the expression which is opposite to this. It is not food, peanuts. Now find expression which is food, peanuts. And in our expressions we have seen that there is expression not eat yx or kill xy or food x. So this is positive expression, this is negative expression, it will cancel out. But there is x, there is peanut, so we have to make substitution, x with peanuts and y with anil, because we need anil also. So y with anil and x with peanuts. So our expression becomes not eat anil peanut or kill peanut anil or food peanuts. Now foods, peanuts and food peanuts are equivalent expression, but this is positive and this is negative. This will cancel out with this, and we are left with only, if we resolve these two, we are left with not eat anil peanuts and kills peanut anil. Only this expression. And again we have to find expression which is opposite to either this or this, and we have expression eats anil peanut. So we'll resolve these two. Eats anil peanut is positive, not eats anil peanut is negative. They will cancel out, and we are left with kills peanut anil. And similarly we can find, we have expression not kills peanut anil, and if we, these two also cancel out and we are left with nothing, that is nil. Means we have proved this contradiction. This is not true, it leads us to nil result. So it means our taken statement is false and opposite it will be true. So John does not like peanut is false. It means we can say not likes John peanuts is false. So likes John peanuts is true, which means John like peanuts. So this is the method of resolution.